derivative rules for other trig functions. So we've covered sine and cosine, but there are 4 other trig functions that you may see show up on the exam. So let's start with tangent. That's the next one after sine and cosine usually. So we're going to start by just rewriting it as sine over cosine. We're not going to use the limit definition. We're just going to rewrite tangent as sine over cosine. So we're going to say y equals tangent of x, which equals sine over cosine. So the derivative of that, dy over dx, is going to be the quotient rule. Low d high minus high d low all over low squared. Okay, so what we've got here is cosine times cosine is cosine squared of x. Negative sine times negative sine is sine squared of x. And that's all over cosine squared of x. Now, hopefully you did learn this trig identity, that sine squared plus cosine squared, or cosine squared plus sine squared, because the order of addition doesn't matter, equals 1. So we're going to replace it with what it's equal to, a 1. And then 1 over cosine is equal to secant. So the derivative of tangent with respect to x is equal to secant squared of x. So you just need to memorize that, okay? You just need to memorize, add that to your list. The derivative of sine is cosine, derivative of cosine is negative sine, the derivative of tangent is secant squared. Now, I could similarly derive the other derivatives, but we're just going to memorize those, okay? Cosecant is negative cosecant cotangent. One way I remember that is all the cos go together, okay? Cosecant, cosecant, cotangent. And just like the derivative of cosine is negative sine, the derivatives of all your cos are negative. So cosine, cosecant, cotangent, all of those are negative. The ones that aren't cos, sine, tangent, and secant are all positive. Okay, and secant, secant, tangent. Okay, and cotangent is the opposite of tangent. So if tangent secant squared, then cotangent is negative cosecant squared. Okay, so those are just, you need to add them to your flashcards and memorize those derivatives. So let's use them. Okay, find the derivative of the following functions. So the derivative of this function, y prime, the derivative of x is still 1, minus the derivative of tangent is secant squared of x. Now, anytime you see a trig function squared and a 1 with it, you should kind of think to yourself, I wonder if there's an identity here that I should be using. So this is our basic Pythagorean identity that all the other ones come from. Sine squared plus cosine squared equals 1. Okay, if we go through and divide everything by sine squared, okay, divide every term by sine squared, which we can do as long as we do it to all of them. Sine squared divided by sine squared is 1. Cosine divided by sine is cotangent, and 1 over sine is cosecant. All right, well, that's not what we're dealing with here. We're dealing with secant. So if we do the exact same thing, but we divide by cosine, we get tangent squared plus 1 is equal to secant squared. Well, we have 1 minus secant squared. So let's see if we can manipulate this equation so that it's 1 minus secant squared. If we move the secant squared over, then we've got to move the tangent squared over. Okay, hopefully you can see that without me having to show all the steps. But pretty much those are just flip-flopping sides, so we have to change their signs. So 1 minus secant squared is equal to negative tangent squared. Now, I don't know whether they're going to make that substitution or not, but a lot of times they do. So whenever they have the what we call the Pythagorean identities, they are sine squared plus cosine squared equals 1, and then the other two versions with cotangent, cosecant, and secant and tangent, okay, you should just kind of be aware of that. Example B is a product rule. Okay, we've got x times the secant of x. So f prime of x is the derivative of the first is 1 times the second plus the first times the derivative of the second, secant x, tangent x. Now, a lot of times in the past, I've had people get lazy on me and they don't write the x's. Trig functions mean nothing without a variable. You have to have the x or the theta or the t or whatever they put in there. You have to put it in there. Don't get lazy. Don't leave it off. You got to keep it in there. Now, they may factor this one. Okay, both of these have secant of x in them, so they may put it in factored form. As I was mentioning before, factored form usually is the most valuable form to us. So if you can factor, it can't hurt be in the habit of doing it. All right, let's look at this one. Find the derivative of the function two ways. So we've got 1 minus cosine of x over the sine of x. So to find that derivative, we would have to use the quotient rule, right? Well, that is equal to, if you decompose that fraction right there, 1 over sine is cosecant, cosine over sine is cotangent. You can decompose that fraction so that it's not a quotient rule anymore, but we should get the same thing. So let's do the quotient rule part first. Okay, so low d high, derivative of 1 is 0. The derivative of negative cosine would be positive sine minus high d low all over low squared. So let's simplify some things here. Sine times sine is sine squared of x. Distribute, let's just look at that as distributing a negative cosine. Okay, distributing a negative cosine here would give us negative cosine of x. Negative cosine times negative cosine is positive cosine squared. Okay, we've got sine squared plus cosine squared. We can put those together to give ourselves 1. So we've got 1 minus cosine of x over sine squared of x, which, if we decompose this fraction, we've got, let me write it right here, 1 over sine squared, in case you're having trouble visualizing that, minus cosine of x over sine squared of x. Let's see how much room I gave myself. Okay. 1 over sine squared is cosecant squared of x. Let's go a little bit further with this one right here. Sorry to jump back a line, but that's cosine of x over sine of x times 1 over sine of x. That's one way we can look at it. So cosine over sine is cotangent of x, and 1 over sine is cosecant of x. Now, I don't like that order, because for whatever reason, I like cosecant to come first. But we could also factor this one. Cosecant of x is cosecant of x minus cotangent of x, because both of them have cosine. All right, so if we take the derivative of the rewritten version, so I'll do this in a different color. So when we rewrote it, it was cosecant, right? So the derivative of cosecant, all our cos are negative, so that's negative cosecant x cotangent x minus the derivative of cotangent. The derivative of cotangent is all the cos are negative, so that makes it a plus, and it's cosecant squared. All right, so we can factor cosecant x out of this, so we get negative cotangent of x plus cosecant of x. Is that not the same thing as right here? I've just got it in a little different order there. The same thing, okay? So in this case, and typically, if you can kind of algebraically manipulate something first, usually that's going to save you some time when it comes to, as opposed to using the quotient rule and simplifying things there, okay? I had to do several things here that you've probably forgotten about: the sine squared plus cosine squared, decomposing the fraction, replacing sines and cosines with cotangents and cosecants. There was a lot of simplifying there. But if you start with just decomposing the fraction, okay, but you got to be careful. The only reason why we can do that is because it's over a single term. As long as it's over a single term, you can split it up. Put the first term over the denominator plus or minus the second term over the denominator, and so forth and so on. Okay. Okay, here's another problem to practice, kind of a ticket out the door, multiple choice AP style question. So pause the video, see if you can do it, and then come back for the explanation. Okay, this is a good example of a product rule mixing with our exponentials and our trig rules. So product rule first. So the derivative of the first it's an exponential, so it is itself times the second. Plus the first times the derivative of the second. Derivative of cotangent, it's negative. Cotangent is cosecant squared of x. So let's look at the answer choices, see how they have them written. I don't see one that looks exactly like ours. Again, look at what they did right here with A. They're trying to make you think it's, a power rule, but power rule does not apply to our exponentials. A is out. So then we've just got to be careful. We got to factor and see which one matches here. We've got cotangent minus cosecant squared is what we should have. So this is C. And then I've got some problems here for you to practice. All of our rules mixed together.